Today is an exceptional opportunity in the world of language learning and makes such with technology. Let's understand how technology can take the next step and understand linguistic meaning. First, Chris, could you please introduce yourself and what do you do for business?
Okay, I'm Chris Lonsdale. I'm the founder of Kung Fu English brand, which is a brand that helps Chinese people learn English through mobile learning, mostly on iPhone or iPad. And I've done a lot of different things. I've done organizational development, senior leadership development. You can call it coaching, but it goes beyond that. Around the Asian region for about 30 years. And have quite a broad and eclectic background. I'm also an advisor in Pat AI, which is John's company.
Let's go to John. John, could you please introduce yourself and what your business? Then we are going to discuss how did you came to relate to Chris.
Right. Yeah. Great. And thanks for having me on the show. I founded Pat Inc. in 2016. It's the culmination of work that I've been doing in cognitive science going back to the 1980s. So it's been a long journey. Pat Inc. is focused on bringing human language to machines. We see a world where people primarily interact with their devices with language if that's how they want to do it, or with other methods if they're more appropriate for the problem at hand. We're looking at multilingual interaction with a meaning-based system. And I think as we explore the questions today, I'll be able to elaborate a lot on that.
So where does Chris fit into your work?
Well, Chris has been an advisor now for quite a few years. And the intriguing part about Chris, we sought him out in the early days, probably around 2015, when we found the work that he was doing, and his interest in neurolinguistic programming, which I'd also studied at one stage, just seemed really relevant to us. And when I talked to Chris, we had a meeting of the mind straight away, because we work in the same area based on how brains work, and his expertise in teaching I found really probably very heartwarming that I could just have a conversation with somebody in a different field, but using my expertise in the machines to potentially have some good synergies there.
Okay, let's go to Chris. How codable is language? How can you feed language into?
How codable is language?
Yeah.
Language is a
yeah.
Language is a code. Language is a code.
How would you feed language into a program?
I guess John will probably back me up on this. You don't. You don't actually try and code a program with the language. You create a program that understands how to pull elements that have meaning and make sense of that meaning. So I guess when you're thinking of coding language, you're looking at line by line. You have the language coded in, and then if there's then that sort of loops. It doesn't work that way. The human mind understands language because it connects sounds to internal representations. And what John has done with Pat is say, okay, let's replicate what the brain does, but in a machine. So the machine is again picking up strings of text or sound, and then saying, okay, so what are the chunks and what is the underlying meaning? So you've got sort of the processing part, and then you've got, I think you still calling it a dictionary, John, or are you calling the encyclopedia?
Yeah, dictionary, encyclopedia, they overlap, interlock. Yeah.
Yeah. So does that sort of make sense from your point of view, John?
Oh yeah, definitely. And in fact, the interesting part I find about how to program a machine is the basis of this goes back 100 years. There were people like C.S. Peirce, Charles Sanders Peirce, who wrote about how language is based on these meaningless words, so the sounds of words, and they connect to meaning, and then you manipulate meaning in order to interact. So that theory lasted really well until about 1960, and then people decided they'll forget about meaning and they're just going to focus on recognizing language by parsing it, by taking parts of speech and creating parse trees and somehow working out the meaning later. And we've never got to the meaning later in that traditional field of linguistics, because it's an impossible task. You can't convert language into parts of speech and then get something that's not highly ambiguous, you know. So if you say a simple sentence and you have 10,000 choices amongst the possible parse tree outputs, then, you know, how would you know which one to choose? But with meaning in there, it becomes possible.
Right, like for instance, hang the hanger in the hangout.
Yes, language gets complex very quickly.
Okay, let me jump in and then ask Chris here, like what mental processes or what brain processes did you depend on to build your understanding program?
For John, right? So
yeah.
Oh.
Yeah.
So if you're like me, you would have gone to university and studied cognitive science. And as a boy, I was fascinated by Star Trek and these computers that would talk to you. So ever since that point, I've always been trying to understand how a computer can do the types of things that a brain can do. And I got to the point where I realized that computers are nothing like a brain, and that the similarities are so different. My analogy would be with a computer, what we do is we store things as symbols, we encode them and store them, and then we copy them and replicate them all over the world. So the internet has an uncountable number of, you know, letter A's stored all over the place as part of words. And in order to find any information in that mess, you need to build a search engine with a search index, and then you work through your index, and you use computer science to now get access to the information that you want. That's nothing like a brain, because if I had to rely on my brain doing something like that, I'd be sitting here for hours not with a blank expression while my brain's going to do all of this crazy work. So I realized that the system that a brain uses is so radically different that we shouldn't use the computer as our inspiration for language systems. We should use our brain as inspiration. And then it comes back to, well, what's the brain doing? Well, we've got all these sensors going in, and I came up in the 1990s with an idea called pattern theory, which says, and this is the funny version, all the brain is doing is storing, matching, and using hierarchical bidirectional link set patterns, right? So, okay, that was the funny part. But what that means is that each of the sensors are storing patterns, and then they store them in a hierarchy. So once I meet somebody, I can see you in all sorts of different angles, but I can still recognize you without having to process that. I just store multiple images of you. But that's not enough, because it's not just what you look like, it's what you sound like that I can recognize, and the environment that you're in that I can recognize. And all of these are different senses, and somehow we pull them all together in our brain and use them. And so that model of this hierarchical pattern matching machine using multiple senses has got to be the foundation for what brains are doing. And it's not just human brains that do it. When I call my dog, she responds equally well to her name. I can clap a certain way. She can just see me, and she's got the same capabilities that I've got to recognize this multi-sensory environment and take action based on it.
Let's go to Chris here. Like now we are seeing that this program is able to use like different, let's say, techniques and different ways of thinking. Like how close is that to a teacher functioning in the classroom?
Okay, I think they're quite different things. So what John is working on is the ability for a machine to interact with a human in a way that the human will perceive as human-like. So for instance, the example that John gives is dictating, right? Call Nour, no, Peter. And none of the systems today can handle that. But with the pattern recognition approach, the pattern approach that John has developed, the system will understand that the no is a negation of what just came. It will ignore that, and then it will say, call Peter, and it'll say, okay, I'll call Peter now for you. So that's what that system is doing. What I've been doing in our learning systems is mirroring the process of children growing up learning their mother tongue. And there are foundational skills that you need to get. Like, you have to be able to hear the sounds of a language. If you go to a new country, new language, you won't hear the sounds. It'll sound like mush. It sounds really fast. The sounds are not clear. And that's because you haven't built the filters in your brain. So you need to get through that stage. You need to get through the stage of connecting physical movements with the sounds that you're hearing. Open your mouth, put that down, come here. These are the stages that children go through. So when you understand how, and you'll understand this, that the child is actually developing patterns of understanding. This sound matches this object. This sound matches this movement. Okay, so the child is developing all of these patterns that, as John was saying, go into these hierarchies of content inside the brain, and piece by piece learning to recognize those patterns very quickly and to respond to them very, very quickly. And so you need to understand that as you're developing a course. In terms of what Pat is doing, one of the reasons I was very interested to get involved with the PAT project is that a lot of adult learners, when they're learning a language, they struggle with having a conversation more for emotional reasons than skill reasons. So they will have a brain freeze because they have to talk to somebody, and there's all this fear involved. So I was, at the time John and Beth reached out to me, I was already looking for a system that could be built where inside a digitally based system, a person could have a conversation, very simple conversation, the sort of conversation that would drive an adult mad. If you had to do that conversation 20 times a day, you get bored silly, but a machine can do it over and over and over and over again. So I was looking for a way to have human-computer interaction as a bridge into human-human interaction, helping with the emotional issues. So in terms of what Pat is doing, Pat allows for the development of lifelike interactions that don't require a human in the middle. So the technology, I think it's fair to say, John, is already there. The content probably still needs to be built up, correct?
Yeah, that's a good summary. And in fact, in terms of the model, the original algorithm that I used to drive this meaning-based system was built in 2006, 2007. And when we added other languages, so we started only with English because that's all I speak, badly as you can hear. And then if you look at French and German and Korean and Japanese, they're very different languages in terms of the structure, the characters that you use, and so on. But the meaning engine that drives the whole thing, that basic algorithm of pattern matching, has never needed to change. And if you figure that every human being with our brain, we're capable of learning any of those languages, as certainly superbly as a child, but then later on we can learn second languages if you have experts like Chris to help you get there, then yeah, you can see that the process has to follow something like that.
Let me ask you, John, here, like basically in education, like at the direct method is one of the most expensive ways of education where you get your child to work with a native teacher. Like how natively would people work in on the program?
So as a language learner, working with us, so that's a really good Chris question, but let me give you my perspective on it, because I had the opportunity of doing one of Chris's introductory courses. So my brain theory worked on that idea that your senses are picking up information, and then somehow there's a hierarchy which has to be learned, because English, for example, couldn't be innate because it's so random. And when I did Chris's course, he had this tape where you're hearing these sounds of somebody speaking English, and if you don't speak English, you can't pick anything out. But over time, you start to pick up the syllables that are making up the words, and then you can start to pick up the words. And it's not a question of thinking about it, it's a question of experiencing it. So being immersed in this environment, which is, you know, part of the neuro-linguistic programming methodology to experience something, it just over time then gets to the next level of, now I'm recognizing the words, I've got to recognize the phrases. Now I'm recognizing phrases, what does that mean? And what my software has been doing is emulating that next level above. So we're not focused on the sounds and the syllables, but we're focused on, if I match this word, what does that mean and how does it go into a phrase? So that if you had a complex phrase like the man bought a large suitcase from the dealer for $500. So there's a few different moving pieces there. We're breaking it up into just a couple of elements that we can then carry on a conversation with. So you could say, what did the man buy? And I'm not sure, can't remember if I said buy or sell, but all of these elements in the language go together and allow us to then produce what is language. So I hope that helps with my view of the learning process.
Yeah, so back to this idea of direct tutoring. I have a fairly strong view on this. You can't teach language. Language is learned, and it's learned through a process of focus on meaning and relevance. And so children learn their language by responding to their parents physically. They respond with actions. Then they start to mimic little pieces, and then they try to say little chunks to make things happen. So my want water. My want water. Water. My want. Okay, you want some water? Yeah, my want water. So it's through this process of actual dialogue that at the end of the day we learn to master a language. Now, as an adult, you get most of what you need through input, which means you're hearing a lot and you're able to connect that to the underlying meaning. And then you need to get to the point where you pull it out and start to use it. So you've got recognition memory, which forms fairly quickly with lots of exposure, but then you have recall memory where you need to pull it out, and that actually has about 4 more steps in the processing that you have to do in order to pull it out. But I see around the world a lot of people sort of try and have someone teach them, when in fact that's very, very low efficiency. You need to, in today's world, you can use digital media, video, audio, do lots of listening, play games, all sorts of stuff to develop first of all, your understanding for it, then your memory, and then you can go to the point where you start to interact. And that's much more efficient and much, much cheaper. You know, hiring foreign teachers to come in and sort of do a class for your kids is very low efficiency. In China, in fact, what's happening right now, recently, the government is cracking down on all preschool and all what do you call it, bushiban, which is the tutorial class businesses under 16 years of age. So basically you've got hundreds of millions, billions of US that's been invested in all these businesses that are providing English for kids 3 to 5, math for kids 3 to 5, you know, after class stuff for kids. It could be English, it could be other things. And the Chinese government has just come in recently, and this is about to be promulgated, and they're saying, sorry, that all stops. Boom. And for very good reason, because I did a TEDx talk in China a few years ago now at a school in Zhengzhou, and one of the points I made was the kids are getting up at 5, they are staying up until midnight, they've got their homework, they've got these tutorial classes, they've got to go early in the morning, they're falling asleep, and nothing's going in. And I said, you know, I went through how do you learn, and I said one of the things you have to do is to get enough sleep, because learning is a physiological process. It requires brain changes, and if you're exhausted, those brain changes don't happen. So it's a complete waste of energy and time. And there was like 200 kids in this auditorium, along with adults and everything else. The kids stood up and gave me a standing ovation when I said the kids need less study and more sleep.
Yeah.
I can think of a good analogy that goes with that too. So there's certain things that brains learn through experience, like language. Imagine if you wanted to become a tennis player and you sat in a classroom and somebody drew a picture of a racket and they held the racket up and they said, what you need to do is have the racket going from low to high and in part topspin on the ball. You could talk for years to these students about how to play tennis, but put them on a court, let them play for 3 or 4 hours a day or something, and they're going to get good really quickly. And so some things you learn by doing, other things like mathematics you can do by sitting at a table and doing the calculations and learning that way. But I think that's a good differentiator between
Absolutely
those types of activities.
Let's go to John. Like, what is the role and reference grammar? Grammar is a very lovely word in the world of language.
Yes, it is. It's been very popular for a long time. Role and reference grammar came from the work of Bill Foley and Robert Van Balen. And I'd been working on my project from 2006 till about 2011. And I'd hit this roadblock, which was I could recognize the grammar of a sentence. And I had a way of reducing the number of matches that I got by not using parts of speech. But I knew that the missing piece was, now that I've got the structure of the sentence, these pieces, the phrases, what does it mean? And I thought, oh, yeah, that's hard. That's a good problem. And I decided I'm going to dedicate the next 30 years of my life to solving this unsolvable problem. It's really big. I wish, all the study I'd done, I wish somebody could have done this. And I visited my sister, I grew up in Princeton, New Jersey in the US. And I visited my sister who's still there, and she took me to a coffee shop. And I pulled this book off the shelf that was just there for sale, and it was a thing called Role and Reference Grammar. This lady had been a student of it, and she'd written about it. And I picked up on one thing, which was when you clap, it's this instantaneous event that then disappears, like there's no change of state. And then another picture was about somebody dancing. And I thought, oh, that's interesting. So I bought the book, and when I'm flying back to Sydney, where I was living at that time, I'm reading through it, and I thought, oh, this is the answer to my 30 years of work that I don't have to do now. So role and reference grammar takes language, converts it to meaning, and explains how we use language. And it's just remarkable. All of this work is not being taught to our current students of artificial intelligence, natural language processing, and so forth. And as a result, companies like mine get the opportunity to exploit it without that competition. But at some point very soon, people are going to notice that they need meaning, and RRG, role and reference grammar, already explains how it works. So that's my quick introduction. That's what it does. I'll just mention one other thing, that when I started working with Van Balen, he was able to explain what his inspiration was for it. And most linguistic models have been based on English or European languages. And him and Bill decided, what would a linguistic model look like if we based it on diverse languages? So he took the Lakota Sioux Indian language from around the California area, plus English, plus the national language of the Philippines, some Aboriginal Australian languages, and then you can go to lots of other languages that are even more crazy than those ones. And he looked for the commonality amongst all of them, and he found that meaning is consistent across all of them, different ways of getting there, different ways of building the sentence structure. And so by that analysis over the last, well, since 79, I think he started it, they've been able to develop this very rich theory that has professors in all of the major languages and lots of the minor languages explaining how it fits in with that particular way of explaining languages. So maybe, sorry if I went on a little bit there, but that's RRG, and that's not even my specialty. That's just something I'm very proud of being associated with.
Yeah, and what is really interesting, what John just said, right? All of the languages represent meaning. And so, for instance, rather than in the work that we do and the way we've developed, for instance, Kung Fu English for Chinese learners to learn English, we avoid traditional grammar. And we come to, for instance, every single sound of a language conveys meaning. Every single sound. So for instance, in English, conveys the sense of a process in play. Id conveys the sense of a process that was in play and that has ceased. So played, walked, walking, playing. Okay, so there's actually a sound pattern ing which conveys that meaning of process, ongoing. So I got to the understanding that every single sound, even grammar is conveying meaning. Most people think that just words, a particular word will convey meaning, but actually the pieces of grammar convey meaning. Like in Japanese, watashi wa watashi wa anata o aishitimasu, right? So I love you, right? But it's watashi wa is from me towards you, love, right? So each single chunk conveys meaning. And so what role and reference grammar did, now I'm not deep into role and reference grammar. I came at this from a different direction, more intuitively, but from my fairly superficial reading of it, it really does focus on how these different chunks convey a meaning. So John, maybe you talk a little bit to causality. Do you have an example around causality?
Yeah, sure. I mean, the deep learning community is very focused on causality at the moment because it's one of the things that you can't do with machine learning. You can't give me 1,000 examples and tell me why there's what the cause is behind those examples. You can infer it, but there's something, there's still that extra step. But language is seeped in causality. So if I say the man walked, you've got the idea of this person walking. But if I say the sergeant walked the men, there's causality. The sergeant causes the men to walk. And just that extra word in that correct position for English converts that into a causal sentence. And there's a lot of more complex ones, like if I persuade the sergeant to walk the men, now there's this extra level of, it's not just causal, they cause that person to make these other people do something. So there's these chains, and it's seeped into the language. And we learn it through experience, and I think our brains are just built to deal with a fact of a cause. So whereas the current NLP community, natural language processing community, is stuck on these statistical models that can't solve certain problems, language already solves it, and RRG is a good way of seeing how that works. And in fact, when you start to look at the decomposition of language, the meaning of simple sentences, you realize that it's everywhere. For example, the word kill. If you kill someone, you cause them to become dead. So dead is the basic state, and then kill is caused to be dead. The reason we have these types of words in a language is because it's much faster to speak. You can imagine if you always had to say, he made this happen, how much slower it would be. So depending on your culture, you'll have words that allow you to do very complex descriptions with one short word. Another language might never have that scenario, so why would you have the word in your language? So that's where the cultural aspect comes into cognitive science.
And just a real simple example, bring. Bring is carry, cause to carry, come. And take is cause to carry, go. Take it to him, bring it to me.
And as Van Balen says to me, some languages, the way he's been able to decompose meaning is some languages actually use the expression take or bring cause or something. And if the language has a word for those two and they use them in that sequence, and then you've got an English word like bring, you can then say, oh, they're talking about the same concept. And once you've got hundreds of languages at your disposal to analyze, you can then start to get a very common feel for all languages.
Of course, the only way this works is that our perceptual experience is very similar. If we were living in different universes with completely different perceptual experiences, it would be much more difficult to create that map over between languages, because the language would be describing completely different substrate of reality, which maybe there is no match to.
Yeah. So this object here is a cup or a mug, and I think most people on the planet would recognize it as that type of object that you drink from. And as a result, if you've got a word for it in those different languages, then people have the perception of what it is, plus now a word that names it.
But what interestingly, different languages are going to cover it differently. So with John's example, that's a mug in English. We would be unlikely to call it a cup. A cup would be smaller, a little bit more curvy, round. It's going to be different in different people's heads because different people have categorized their world a little differently. But in Chinese, there's one word, basil.
Okay, yeah.
Right, and then glass is actually boli bei, which means this vessel made of glass. So the underlying meaning substrate is the same. The way that the sounds are mixed and the way that the different sounds are chunked up into what part of that meaning they convey is different in each language.
Right, let me go to Chris here. Like, what principles? Let me say, what principles do you use to help John with, like, in the region of the mind, the brain, in the region of linguistics? Like, what kind of things do you base this learning on?
Well, I think John did a lot of his own work, but what was interesting was when we sat down together, we started decomposing some sentences. And John went through these sentences saying, look, this is how we need to, you were using the word parse at the time, but he was chunking. So he was going through and chunking and iterating back based on the meaning picked up later in the sentence would be used as feedback back to the front to ensure that it was consistent. And I said, well, I teach learners to bracket things. Okay, so for instance, give the sharp knife to the really hot, tall lady standing in front of the red door. Okay, and in order to understand that, you actually need to, so it's give the knife to the lady. Okay, the sharp knife. Right, so you've got these really simple pieces, and then we embellish all those pieces in order to keep your brain understanding what's going on. You need to bracket these so that you're getting the descriptors of one thing and the descriptors of another thing. They're bracketed, and potentially this whole chunk is then connected to something else as well. So what we discovered was that my understanding of how you need to be thinking about it, how you need to work with it as you're learning it, was very, very much the same as the way John was having to think about it in order to get the machine to understand it.
John?
I just found Chris's help very invaluable when it came to just looking at what I needed to teach the machine in order to then scale up larger than that. And the types of things that he was teaching his students once he got into the scenarios was really valuable. And if you look at the pure science of linguistics that I was taught, most of the things that Chris was looking at were too advanced for even these existing sciences. And so by taking what students need to be taught and applying it to my work, I was then able to build test sets so that I could have the simple ones first, and then we can start using those chunks of other information and putting them inside these tests and making them more complex. So
you mentioned that, yeah, so sorry, John, go ahead, John.
No, that's fine, continue.
You mentioned that, like, what Chris did was quite advanced to what other people did. Well, what do you mean by that? What pieces exactly, like, got your interest in Chris's work?
Well, for example, the saturation in the language. You know, Chris explained a story about how he started to learn Chinese by being immersed in in a train and having this person talk to him, and he over a period of time started to get Chinese. That's that same principle of learning those basic things and then building up was valuable for me. But anybody in the cognitive sciences often has some useful insights to share with others, because as a rule, we tend to in science get very narrow with what we're focused on, and then we keep improving it. Then you see a real world example that, you know, a 3-year-old kid can master, and you realize, oh, I can't handle that. How do I do that? And Chris's expertise was just showing me this range of things which are very simple that my model wasn't coping with, and I wasn't even trying to solve, because that was like, no, we do more complex things.
Yeah, and in fact, for humans, unless you solve the simple ones, you never get to solve the complex ones. These are foundational component skill sets. And all of the complicated stuff, you're reading really complicated papers in science, or you're writing very complicated papers, they go back to the top 3,000 words plus metaphor, plus some specific technical words that have very, very clearly defined meanings. But you can't start with that technical stuff. You have to deal with the glue. You have to be really good with the glue. And that involves some of the predicates, right? So for instance, for language to body, John, they're the things that a kid is going to have to be able to master in the first year or so. Yeah, that's not stuff that anybody would be looking at for linguistic processing with machines.
Right. Yeah.
But you've got these simple phrases that are just completely obvious to a 5-year-old. And you actually have to know how to do them first, because the 5-year-old can then go ahead and understand Harry Potter later on because of what they were able to do at 5. If you jump over that, then in the second language, you give someone Harry Potter, or even in China, they get 4-year-old kids or 5-year-old kids, and they give them English language only materials. So for kids, so these are materials prepared for English language, native language speakers, and they give it to Chinese kids, and they expect that the Chinese kids are going to be able to speak English because they're looking at this material. But if you know Dr. Seuss, you will understand that the language in Dr. Seuss is actually highly complex. and the native speaker gets to play with that language at age 5 or 6 after he or she is already speaking fluently. They don't have a lot of words, but they've got the language in terms of all of the customary ways in which it's used. So they're recognizing all the patterns, even though their vocab is limited. But you give that stuff to a non-native, they don't have the patterns, so they absolutely are lost. So I think part of what happened when John and I started working together was that this consensus that you really need to solve these core communication issues first. And I think that's probably helped lead into the goal-directed communication, John.
I'm sure, yeah. The most advanced system that we're working on is a system of goal-directed conversation. And where it came from was we were working with a virtual reality company, and they wanted to, at particular points in their environment, they wanted to ask a question and get an answer. And when you think of it in virtual reality, you could go to a bus stop or a train station, or you could be on a street corner. And the question you ask, like, what should I do now, changes depending on where you are. So when you're at the bus station, what should I do now? Catch the 5:32 bus. When I'm at the train station, catch the train to Central Station. So you have to change what the conversation is going to be depending on where you are. And believe it or not, that applies really well in general to conversation with machines, because if you say went to a store that was, you wanted to find something, well, you want to be greeted first. Hi, how are you? How can I help you? And, oh, I need to return this product. Oh, and then you're in the returns area, and then the returns is going to have different language, different goals to, oh, I need to buy something. Here's the sales manager. So that goal-directed conversation is something that is hard to exploit with a statistical system, because you're just looking at the entire world through the lens of the things that you've received before. Whereas now we're able to compartmentalize and navigate a user from the greeting to the goodbye, or the annoying, would you like to do a survey at the end of the transaction.
And it's exactly the same thing that applies to a language learner. Because if I said to you, pick it up right now, you're not going to understand what I'm talking about. Right now, if a kid is at home and throws something on the floor in a tantrum, pick it up. Right? Or if you're a sports person in training and you're a little bit lazy and your coach says, pick it up, they mean something very different. And very often people get completely out of it. They really can't learn because they're not understanding, and they can't understand because they don't know the context. If you've ever met with a married couple who've been together for 30 years and they're having a conversation, you generally don't understand 30% of what they say, because they are referring internally to a history that is common to them both, but not to anybody else. This is why they're saying that you need to go into a foreign country and immerse and you'll learn the language is partially mistaken. It's not 100% mistaken, because if you know how to brain soak and other things, and you know how to use body language, you can overcome those challenges. But for a lot of people who don't have that sensitivity, or even realize they need to be doing that, it's a challenge. So if you go with a group of friends, say you went to Germany and you were a group of German friends and you don't speak German, you could spend months and not learn anything. And you've got a couple of things going on. They're going to have their conversations, and they're not going to want to downshift to a 2-year-old to have a conversation with you. And they're talking about movies. They're talking about 20 years ago at school, that particular incident with those particular people. There's no way you're going to understand what's going on. So you have to narrow the context and make it very, very tight. So the context is defined and the learner knows what the elements of the context are. And then he or she can actually work with the language around that context. So if you're rigorous on maintaining that strict boundary around the context, and you only use the language related to that, you can begin to expand that context over time so the learner is able to follow along. But you can't jump them in the deep end. So one of the things that John continually got really frustrated about was that people want your language machine to understand 500-year-old poetry instantly before it knows how to open the door.
Yes. Hark.
Right.
What light from yonder window breaks? It is the dawn. Oh.
and you know, a system that is trained to the point that can handle 3,000 of the most common words and phrases in the language and interact on daily stuff is not going to be able to understand that, because there's vocab and this context that it's never met yet. So I think it's really, for me, it's really, really interesting how this process of training the machine and this process of helping a person to learn overlaps in so many important ways.
Okay, another question for you, Chris, here. Like, how effective would education be if based on, let's say, the linguistic principles?
All right. If you're based on traditional linguistics with parts of speech and everything else, it's going to be terrible.
I agree with that.
It's going to be terrible. If you base it on an understanding of human neurology and brain science, and how humans process language as a sound system that is a labeling system for the world or for what's going on internally, and you allow them to have multiple repetitions over time so their brain recognizes the patterns. So that form of linguistics, it's extremely effective. To give you an example, there's a woman who is in China, and she had spent 4 years on her own using textbooks and copying stuff and writing stuff, couldn't speak a word of English. She got Kung Fu English, which takes you as a baby and grows you up. And in 2 weeks, she was having conversations. Within about 3-4 weeks, she was like playing with her son, and they were listening to the audio and following the commands and giving each other commands. And then one day she was in the shower with a new shower head, and she said in English, "Oh, the new one's better than the old one." And her son, who's only like 3, said in Chinese, "Oh, meaning so the new one's better than the old one, right?" And she's going, "Oh my God, he's picked up all this English just from me playing it out loud and playing these games based on the guidance in the course." So it's really obvious that if you follow the process that a baby uses learning its mother tongue growing up, and you add a little bit of what I call the adult advantage, where you can put a little bit of logical structure on it to help you get what's going on faster, then 6 months to fluency is not an idle dream. Now, if you're all day, every day, 6 months is pretty much guaranteed, as long as you're doing it the right way. If you're an hour a day, it might take you a couple of years, but even that, compared to 20 years and still not speaking, I think is a significant improvement.
In fact, I can reinforce what Chris is saying just by giving you an analogy with science, that linguistics and brain science definitely can radically improve how we train people in languages and lots of things that people want to learn. But back in history, up until the 1400s or so, people were sure the Earth was stationary, and there are these the sun and the moon went around us with the planets. And even though it didn't really match observation of what we could see, that's truth. You could teach people that, and people were taught that. And when you tried to change the theory to something else, there was a lot of anger about it. And it really took a long time, many hundreds of years, before people started to accept, okay, well, here's the new model, and now we're going to teach that. But with linguistics, there's so much old stuff that people are still being taught that you can't apply. And if you can't apply a theory, what's the point of teaching it? Whereas in Chris's environment with his teaching method, people do learn, and they get good results. So what we need to do is morph to the things that work, which is pretty much the scientific process. Find something that works, start to use it, and then improve on it. Over time, we're going to be a lot better for it. And at the moment in the linguistics community, there's a big divide between the people that are pushing statistical models versus these analytical models. And until we start to say, well, these ones don't work at all for these particular problems, we're going to be stuck saying, oh no, you can't change it because the sun comes up every day and the earth must be solid because I don't fall over. Silly stuff like that.
And masks work.
Okay, my question here is for John. What is the last interface?
Well, for me, the last interface is human language. It's the last interface we'll ever need. In Men in Black, that's the last outfit you're ever going to need. And when we're talking about working with devices, the fastest way for us to communicate is with language. In Hollywood now, I think because they're so disillusioned with progress in artificial intelligence, they're pushing for these holograms where you open something and you start pushing in the air, and you're controlling complex machines with holograms. But really what we say with language is far more powerful, clear, unambiguous. So once we get language to work properly, it's going to be what people talk about as voice first, where the first way you interact is going to be with voice. There's obviously times when you don't want to use voice. You're on a train and somebody's sitting next to you. You don't want to have an intimate conversation with your machine about something that you don't want other people to hear. So you'll use other techniques. But voice is definitely very fast to get your message across.
Maybe.
and visual input is a very good way of getting responses back. So for example, if you want to choose a seat in a bus, you don't want to do that all with language because it would be very cumbersome. like the third row back, if you show a picture to somebody which has all labels on the seats and you say, what's seat 3B, you're done. So you can use voice with the other modalities that exist and make much better machines. And so in answer to your question, yes, language is the last interface we're going to need for devices.
Okay, I'm going to ask you, yes, go ahead, Chris.
No, and just on that, I have a real simple rule of thumb that there are different ways of doing things, and you should choose those different ways based on the context. So John is saying, there's certain things that you need to have visual or kinesthetic input, and certain things that you need language. It's like, should people come together in meetings? Well, if the goal is to present information in one direction, the answer is probably no. They don't need to be together in a meeting if it's a one-way presentation of information, right? But if it requires feedback and it requires people to explore different possibilities and different angles based on different experiences, then a physical meeting together is absolutely going to be the best thing to do. So a lot of organizations sort of have meetings and they're all people sitting in chairs getting bored silly with speakers all talking one way. That's a complete waste of time. But if you get 20 people in a room and give them a problem and give them a couple of barrels of coffee, then you're going to come up with some really fantastic outcomes. So it's really being intelligent in how you use the various tools and options available to you to solve the particular problems you're trying to solve.
Okay, let me ask you, John, here, is technology easier to train than teachers?
That's a good question. I mean, teachers are people, so you've got the advantage that people are far more flexible than machines as a rule. There's certain things that machines excel in, so you can teach a machine to weld a car. You just take it through the welding motions and it's going to do a superb job compared to a person, because it never gets tired. It just keeps doing the same things that it's been taught, and if it does get out of whack, you can change it and it'll probably work for another 6-12 months or something. So with my area with language, we're still not at the same point of what some people can do. We can talk to a person from another country that doesn't speak our language the same way and still understand them, like me go city. You think, oh, well, what do they mean? Oh, I want to go to the city. Oh, catch that train. And yet a person can do that. A machine is nowhere near being able to do that at the moment. So yeah, I still, and I must say, I much prefer dealing with people, because people are more fun than machines, but it's a good intellectual exercise to make people's lives easier, to give them an interface based on language that understands them and does what they want. So
I have I guess a different angle on this. Machines can do much better what most teachers today do. But machines are a long way away from doing what a teacher should be doing. Mm-hmm. So, for instance, with language, right? Language teachers, not totally, completely, but a large proportion are going to be talking about grammar, doing grammar analysis on the board. They're going to be getting the class to repeat after them. I mean, there's a whole bunch of stuff that language teachers do, which you're going to get much better results from a human machine interface. So, you can be like in Kung Fu English, you look at the face from the nose to the chin and you listen and you mimic the mouth. And just that process of looking and copying the sounds gives you much better accuracy than just trying to copy the sounds. You can do simple tests. If you fail, you do it again. So there's tons of repetitive stuff that you do through technology. The technology, as John was saying, doesn't get bored, it doesn't get tired. And the learner is faced with this very rigid structure in a sense that when they get it right, they get it right. And when they don't, the machine doesn't get them, for instance. Okay, so that lack of flexibility within this context is actually helping the learning outcome. Now, when machines do that really well, then there's no role for teachers doing that. Now, there is a role, for instance, for language parents. So in a language learning interaction, you don't want teachers, you want language parents. And the language parents' role is completely different. It is, number one, to understand what the learner is saying, even though they may not be very correct in terms of pronunciation or grammar. So as John was saying, you know, me, go there, want. A human is going to be able to understand that. And a language parent would say, oh, you want to go there, right? Yeah, me go there, want. Okay, I can take you there. Let's go together, you and me together, let's go. So what happens with the language parent interaction is that the language parent is a foil for the learner to communicate with, and it's a feedback loop that is not correcting the learner consciously. So there's incredibly high value in the role of a language parent, which a machine is not going to be able to do yet. But it's very, very low value to have humans spouting stuff at the front of a room to a bunch of half asleep people. So again, it's use the people where people can excel in what people do well, and use the machines to do what the learner needs, but a human teacher is going to be wasted, basically. Now, there's going to be a lot of resistance to that because people are in a rut, and you know, they've 20 years, they get up, they go to work, they do the same stuff every day, they don't learn anything new. And so when the machines take on all of the automatic stuff and the repetitive stuff, then the people are going to have to learn to open up and become creative and much more alive once again. I think on balance, that's going to be a positive outcome, but I would expect there will be a lot of kicking and screaming along the way.
So my question is for Chris, like, how do you see the future, like between machines or programs and human teachers?
John mentioned Star Trek. I think the model is the holodeck. So you have these fully immersive environments, complete sensory, you know, you fall in the water and you have to physically swim. Ultimately, virtual reality, even altered reality, is where we will learn. See, humans learn really quickly when they have all of their senses involved and they have to solve problems, right? Survival, solving problems, relating to various aspects of their environment. It could be another person, it could be an animal, it could be whatever. We learn really, really quickly in those contexts without even realizing that we're learning. So ultimately, I think the future of human learning is going to be that sort of stuff. You know, someone in front of a class of people with a blackboard is not going to be the mechanism going forward by any means. Although, you know, drawing scratches on the ground with a stick to communicate something which words don't work for is still going to be a useful thing to do. Right. So again, I think we've taken things that work in some contexts and we've generalized them way beyond their usefulness. And because that generalization added more value than what was there before, those things became the way things were done. But we now have new ways of doing it. And I think the new way is ultimately, you know, if you can spend, as say you're 8 years old and you can spend 6 hours of the day playing with your friends, climbing trees and everything else, you spend 2 hours with a device, and you master in about a year differential equations, and you master another language, and you've read 100 books.
And imagine if you learned some history the same way. I mean, with actually seeing the characters from history doing things, and you get to experience the emotion that goes with that, how much more effective would that be than here's a 500-page textbook on the Caesars of ancient Rome? Go and read that and come back to me. I like that holodeck example.
And I actually think, you know, this is fairly hard on the educational industry, but I think to some extent teachers have become a priesthood, and they're the mediator between the individual and knowledge, and that's a problem. And a classic example, many years ago, I met somebody who was doing a Mandarin class, and they were very discouraged because they come out of that class and they said, I was in the class and I tried saying this to mean this. And I said, awesome, that's perfect Mandarin. He said, yeah, but the teacher wouldn't let me use it because we hadn't got up to that point yet.
No.
Yeah. So I think really that teachers in the traditional system very much operate as a priesthood and the sort of a barrier to learning in many cases. You know, some of the, you know, I've done a lot of work with corporates, and I used to get brought in, because I'm now focusing on the Kung Fu English, but I used to get brought in to facilitate conflict resolution and get strategic direction for major companies. So I'd get the senior team in a room and I'd have them making models with Lego, and I would have them having war games with Nerf guns, and have them mixing up into different groups, you know, 10 minutes in this group and, you know, another 10 minutes in another group, and just complete movement. And we'd be going from 8 a.m. in the morning to midnight, 3 days in a row. And people's heads were exploding with the new information and the knowledge and the new insights that they were getting. And just 3 days in that sort of a high pressure environment, and you would get massive insights that changed the business, and you would get relationships that lasted through years without conflict. So it's really, how do you do this? You know, we already have the knowledge and the tools to fundamentally transform the way these processes work. And I would argue that unless we start applying these things globally very quickly, we're pretty much in very deep trouble. There are phenomena happening in the world today which speak very clearly to the fact that people can't think, they can't learn, they can't communicate. They certainly can't communicate effectively in challenging contexts where people have different opinions and viewpoints, which, if you have the skills to use scientific thinking and empathic communication, you can get beyond those things and come to a consensus which actually makes sense. And right now we're failing as a world now very seriously in getting those sort of outcomes.
Let me go to John here. Like, my question is for you: do you think now you are at a step, at a place where technology can, let's say, can be more successful in the future and the education scope?
So yeah, I think we've seen it with the COVID crisis, that there's technology available that allows us to do something that we couldn't do before. You can work from home with very little interruption to things that, you know, you still interact with people. You just call them up on Zoom or one of the other products. And you can draw things on the board interactively, you can share files. So we've already seen this opportunity to radically change how we do day-to-day business. And I know over the last few years, you can tune into programs of top professors talking about their field to their students, and you can learn remotely that way. I think for free a lot of the time. So, why not take the latest technology and apply it to all sorts of new things as we move forward? In my area of the language understanding part, we're keen to see people working with machines more naturally, but there's no reason for people not to work with each other more naturally and use the tools available. If I need to talk to somebody in New York, why hop on a plane and fly over there if, it takes well, from Sydney to New York is like a 24-hour exercise. And then you're all jet lagged, and then you have your meeting, and then you come back, or you wait for a week to try and recover, and then you come back, and then you recover for another week when you get home. So there's all that type of thing.
But as soon as the teleportation devices are ready, then those flights will disappear, right?
Definitely. Teleportation, that's one, and we'll also have the holodeck. So this is an awesome announcement.
A question for you: What insights have you had from this?
This is the question for me or for John?
Yeah, for you.
I think I agree so much with what you are doing, and I like so much what John is doing, like especially that you said technology can do certain jobs and teachers can do certain jobs. So you are not wasting the efforts of one side or the other. I think that is the basic shape of education. That's the effective way to go forward. And then, like, John's work is so effective and so crucial because you are transforming technology from depending on, let's say, algorithms or formulas or laws to understanding meaning. And then, like, you are exactly like bridging this gap to where you can provide input to the learners with meaning that can speak to the learners. And then you are removing this burden from the teacher's shoulders. You get my point? So the teacher would focus so much on, let's say, the important side, the parts that need the teacher input, that needs discussion, that needs clarification, but not the side that needs practice and a lot of work from the side of the learner. So basically we are, let's say, making the process a lot more effective on both sides, for the learners and for the teachers.
Indeed, and I think a point I think that John would make this as well is that the technology, people are really worried that AI is going to take over the world. The machines working with language and working with human consciousness, working with consciousness is so far away from what humans can do right now that we really don't need to worry about this. When a machine can see, taste, feel, hear, touch, with internal responses very similar to a human, and is got a language capacity around that, plus it is much faster. At that point, potentially there's going to be a challenge. I think we're still a long way away from that. John, I don't know if you agree.
Yeah, the two best applications of AI that I've seen are the Amazon shopping assistant, which says people that bought that also buy this. So that's not a human skill. Like no individual can keep track of millions of products and which products are sold and what they also buy with those products. The other great application of AI is search engine. You type in a few words and it finds you pages that are directly relevant to what your search argument was. Great technology. But the other applications of AI that people are saying is great, like translation, it's not good enough to use in schools. It translates kind of, but you actually need to speak both languages to see just the limitations of them. The other great breakthrough was speech to text. So captioning and things, it's definitely better than it's ever been, but could you rely on that to have a type of interaction with a person? And if you say yes, you definitely could. I'd then say, would you stake your life that it's getting it right? And then people go, no. Because, okay, so it kind of works, and that's great. So we're going on the right path. But until we extend what our AI is doing today from just the things that we're showing off with search engines and shopping assistants, the other things that we're getting the technology to do really aren't at the level that they need to be. So, you know, imagine if you relied on who your employees are going to be based on a machine scanning the CVs and saying, oh yeah, employ this person. Well, why are you saying that? Oh, because it's the best. Well, why is that? Don't know. And that's the types of things that over the next 5, 10, 20 years we'll keep improving on. But the first thing is we've got to shock people out of the idea that everything's solved by the current technology, because it's not, and then start looking at what else can we do to make this technology better. So I'm hopeful for the future, and I'm pleased with what we have now, but I wish I could come back in 50 or 100 years and look back and see what we've done since now.
It has been more than awesome talking to you, gentlemen. Thank you so much for that, and really, really, really bright future for your endeavors. Thank you so much.
Nour, thank you. Been really great having a conversation with you.
Thank you.